All right, there we go. So good afternoon, everybody. Here we are on our first day of class for ES 2110, which is statics. And the first thing I want to talk about is how you're going to access our course. And in order to access our course, the first thing that you need to do is to go to your student portal, which is available at my.nwc.edu. And from there, you get a landing page that's comprised of these cards that have different topics. So we want to find online courses. Your landing page may look a little different than mine just because I'm a faculty member, so it just looks a little different than a student page. But basically, you want to find the card that will take you to your online courses. And if it's not visible, you can go to the main menu and discover that card, whatever, if you want to say Moodle, for example, and it will make some guesses for you as to what that looks like. Okay, so here it's found this card. Then if this little tab, this bookmark is transparent like this, you can click on it and it will move it to the home page. So that'll make it handy for you as you're working through this and other classes. So here we go to statics, and we do have a couple of course numbers because the course is a hybrid course. So in other words, we have some people who take it face-to-face, some people who will join us by Zoom, and other people who will take it asynchronously. So now that you're all here, there'll be some days when you won't be here, and I won't necessarily hold a face-to-face class every single day. There will always be material to cover, but we may just meet 1 or 2 days a week face-to-face and then meet asynchronously or something differently during the rest of the week. But you always have the option of not being here. I'll be here when I say I will be. I'm very reliable that way, but you guys always have the option of meeting elsewhere. You know, if you're off on a trip, or you know you're not feeling well, or you just you have a late lunch and you're not back yet or whatever. So it's never no harm, no foul. Everything is super. All right. So the syllabus is on the website on our Moodle page. And there's just some contact information for me. And then there's also some information about how this course is going to be graded. So by the end of today, you should know what you need to do to get the grade you want. So, and I've had courses like this where everybody gets an A. That makes me really happy. So makes my grading easy, makes me happy for the future of our country. So so there's a lot of good things about that. So do your best, and if y'all get A's, y'all get A's. So that's there's no curve that is that way at all. All right, so I have the Zoom meeting for our location. I also have last semester and this semester, I tried something a little bit different. Instead of keeping set office hours, I have a link to a program called Calendly, and it's also on the bottom of any email that I send you. But if you go to Calendly, it will show you all the available times that I have, and you can just choose a time, and then that time is reserved for you. So it will assume that we're going to meet by Zoom, but if you want to meet at that time face-to-face, just let me know, and then I'll probably be in my office anyway, but I'll make a point of being in my office if you prefer to meet face-to-face. The other way that you can contact me is by texting me, and you're welcome. And it should be written down somewhere. I'll try to put it on my page. But my phone number is 307-272-1833. You're welcome to text me anytime. You're welcome to call me, but I have not picked up my voicemail for probably 8 years. So if you call me and if I don't see you called me, I will not really know. So texting works better if you can do that. All right. But anyway, email me, make an appointment, Calendly, come to my office, or send me a text. Okay, so what are we going to do in this class? Well, statics is a really interesting class because this is the first class that's really part of the classical engineering suite of classes. And it's a class that's under a larger umbrella called vector mechanics. And vector mechanics have to do with vectors. and it has to do with the way they work. So statics are basically the forces and the effects of things that sit still. So we're talking about the foundational stuff for buildings, bridges, any sort of structure at all. So then after we finish statics, or at the same time, sometimes people take dynamics, the second course in the classical suite, which has to do with things that move. So machines of all sorts, spinny things and linearly moving things and so forth. Then mechanics and materials has to do with the internal responses. In statics, we just pretend like everything is strong enough that it never deforms, never bends, never breaks. How true do you suppose that is? Not very true, right? But we pretend in here, and because we want to look at what's going on externally, then we in mechanics and materials, we look at structures internally, and then finally fluid dynamics, which has to do obviously with fluids, which is really fun too. But so you'll take those courses over the time that you're here and at university, if you're in classical engineering curriculum, which almost everything is. There's another point that I just would like to make that's really interesting about engineering. All engineering programs in the United States, all four-year engineering programs that are worth getting a degree in are accredited by the same body, which is called ABET. And it used to stand for the American Board of Engineering Technology Education. Now it's just ABET. But ABET accredits all four-year engineering programs. And what that does for us is it makes all engineering programs more the same than different. So regardless of where you start and regardless of what field of engineering you go into, your first 2 years are going to be 90% the same. Then, you build on the foundations of engineering, which is general education, math, science, and engineering science. And then the last 2 years you specialize. So the really good news is what you do here is going to be widely transferable. And the other piece of good news is if you're not 100% sure of what field of engineering you're interested in, that's okay, because you're still going to be doing the same things until we get a little bit further along. And at some point it will, if it hasn't, I was just talking with Josh, I don't mean to put you on the spot, but he had a job experience that really made him understand that there was some part of engineering that he really loved. And so that can happen along the way. And then when that happens, you have not wasted any of your time because you're still getting ready for that. Right. So when we talk about vectors, we're talking a lot about trigonometry. Probably saw in the schedule that the prerequisite for this class is Calculus 1. However, if you're in Calculus 1, you're very likely to be successful in this course. There's only a little bit of calculus, and it's in the last quarter of the class. So the last two chapters have some calculus involved in them. The rest of it's trigonometry. So strong background in trig is important. If you are in calculus at the same time as you take this course, if you drop calculus, then we have to have a conversation. But if you're finished with calculus, you're totally peachy and it's all ready to go. All right, so our objectives to understand vector mechanics considerations and apply principles to non-accelerating engineering problems. So I kind of misstated things that sit still. It's an easy way to put it, but we're really talking about things that don't accelerate. They can be moving with a constant velocity, still covered under statics, because the math is still the same. Gain a factual knowledge and terminology, and then to develop the thought process and methodology required to interpret, analyze, and solve engineering problems to the level and in the manner that will be required of students in engineering courses from this point forward, and to present solutions in an industry standard format, which I'll talk about that. But engineering is built on science and math, but it's not quite science and math. It's a little bit, it's its own profession. And engineering is not just an academic discipline, it's also a profession, which means we have an agreement with society, which means we do things for society that they can't do for themselves. And our mission is to protect the health, safety, and welfare of the public. So that's what we do. And so for that reason, we can't just throw up an answer and say, I think this is what happened. A big part of it is explaining why you did what you did and why you thought through something the way that you thought through it. And the explanation is not paragraphs. The explanation is math and pictures. So that's part of what we're going to learn in this class as well. So sometimes I can get a little, I do not mean to be a smart alecky person, but I can get I remember there was I don't even know where it really came from, but there was a thing that happened a few years ago where I had students who told me, I think it was in a movie, but somebody said, well, I can do the problems in my head. And I said, well, yes, so can I. However, that's not what we're doing in here. You have to show me, why you're doing what you're doing and how you're doing it. So this is what I call homework template. This is also placed on your page. Now, the first stuff that we do is just unit conversions. We're going to spend a little bit of time working with that. You do not have to go through this level of detail to do unit conversion problem, but this is basically how I like an engineering problem to turn out. Another thing you may notice when you start looking at homework in this class is that you may have 5 or 6 homework problems for a week. And if you're used to a math class where maybe you have 40 homework problems per week, you may think, oh, hey, this is great. I don't have to do anything until Thursday night. But the thing is, every homework problem is quite complicated. So you have to present it in this sort of a way. Not exactly this way, I don't mean that. I do like the stuff on the top where you put the due date, the course number, and what homework assignment it is, or something to identify what it is, your last name, your first name, and then what page this is of the total. And that page of total, especially like we're going to be handing stuff in through Moodle, so it's not as huge of a deal. But if you misplace or if I can't read a page, I can identify it immediately. If you're handing in pages and pages of stuff, the page number is really, really important. So, and also putting your name on the top of each page, because your homework going to maybe look similar to your classmates' homework. And if I stick them in my book, who knows if I'm going to give you credit for what you're doing or not. So, so we try to we are just trying to make it as easy as possible to follow everything that you are doing. Okay, so the homework template is one of the things you may have noticed is the homework template showed that the homework was done on green paper. And the green paper is something that happens. This is like, I don't even know how to put it. This is the front of a piece of green paper. It's called engineering comp paper. This is the back. And engineers for 50 years have used paper very similar to this. The green is standard, but there are other colors that you can use. However, and then sometimes like engineering firms will have their own engineering comp paper. So if you have an internship with somebody, you can maybe get paper from, TO engineers or whatever, and all that's fine. But the thing that I love is the grid, the grid, and you don't really write on this side. It's just that the grid sort of comes through a little bit on this side. Now, you can buy this through Amazon, and it's just called engineering composition paper, or I have a whole bunch of it in my office. And so I'll put some out on a little table, and you're welcome to as much as you need to do your homework. Don't take your notes on it, but use it for your homework. Absolutely. So it's something that the engineering department, we started buying it a few years ago and just keeping it in stock as much as we can. So, because it's getting harder to find too. Sometimes you can get it like at a big box store, but sometimes you can't. So, it's easier if we just have it here. So there you go. So that's what your homework has to look like, right? Now we say, what is the homework? What are we really doing? Okay, so what we're doing is we're working with not just numbers, but how numbers apply in the real world. And that's why we start with this topic of unit conversions. And when we talk about unit conversions, what we mean is changing from, well, let's see, how would I start? It's a very difficult concept because we live in America and we use a very strange, it's not really even a system of units. It's just a bunch of random things. So my favorite, it doesn't even really have a name. Sometimes I call it the British engineering system, which is ridiculous because the Brits don't use it. And, so I don't know, but that's another story. So I like to call it the US customary system because it's basically arisen through custom. Okay. So the reason I bring this up is, I'm going to go to my screen. Okay, unit conversions. So we use what I would call the US customary units, not a system. And almost everybody else in the world uses the International System of Units, which is also called the metric system. Okay, the metric system works in powers of 10. So for example, if you have a length in meters, the next would be a decameter, which is 10. And then you would have some other things, and you would have a kilometer, which is 1,000. And going down, you would go to a decimeter, centimeter, millimeter. So these are all powers of 10. So a decameter is 10 meters, whatever, I think it's hectometer comes in here, and then a kilometer is 1,000. So it's 10, 100,000. Here it's tenths, hundredths, thousandths. Okay, nice and logical. Everything makes sense. Not the way it works in the United States. And the other part is there are actually 3 countries in the entire world that do not subscribe to the metric system. Does anyone know who it is besides the United States? Answer is probably not, because they're not major players in the whole world. So one of them is Liberia in Western Africa. And the other one is the country formerly known as Burma, Myanmar. And Myanmar exports a lot of teak wood, and teak wood, they measured in something similar to a board foot. So it's an interest, because they get a credit for having a bigger tree, like the branch, not the branch, but the tree. I can't think of the name of it. Anyway, so the bigger it is, the more valuable it is, because you can cut bigger boards out of it. So, so they use a different system because it suits their need to export teak wood. I'm not really sure what Liberia exports or imports, but they do use the metric system. But as of the last time I read something, they had not promised to use the metric system. They'd not signed an international accord. But the problem then becomes the US trades with everybody. And so everybody has to learn a little bit something about the way we do things. But so we just talked about feet. Like a meter is about 3 feet long. It's not exactly 3 feet, but it's in the vicinity of 3 feet, which in the United States is a yard. A yard is about a meter. We'll just say about, approximately equal to a meter. Okay. So a third of a yard is a foot, which is the base unit. And the unit down from that is an inch, which there are 12 inches per foot. And then going up, there's some other things. There's one called a rod or a perch or a pole, which we won't get into till you get into surveying. And then we'll talk about rods and perches and poles. They're 16.5 feet long. And then we go up to the big unit, which is a mile, which is 5,280 feet is 1 mile. And to sort of, you can see this multiplication and division is a lot easier than this multiplication and division, right? And it's easier to express smaller units and larger units in the metric system. So, but I'm not like a proponent. We're not going to just pretend like SI or the US customary doesn't exist. It's very important to us because we get to use it. It's just, I'm expressing to you, it is illogical, and yet here we are. So the word mile, just to finish off this discussion, actually comes from an old Latin word, which is basically millipas, which means 1,000 paces. Okay, and what a pace is, it's 2 steps. So if you take a step and another step, that's a pace. Well, in the days of the Roman centurions, when they were marching throughout Europe, they would always, you need to keep military lines, always need to keep their lines nice and straight and true. So they standardized their pace at 1,000 paces per mile. I mean, they didn't know it was mile, but they just call it, that's where that came from. That's how old it is. So, and if you go out, one of the things we'll do, and for those of you that take surveying with me in the spring, we always measure our paces. And it's really interesting because most people's natural pace is right at 1,000 paces per mile. Mine is within a fraction of an inch of 1,000 paces per mile. I mean, it's just, I can walk anywhere and determine how long it is by my own pace. Everybody I've ever met, except for one person, had a pace. So that means that your pace is 5.28 feet, right? Everybody I've ever met is between 4 3/4 feet and 6 feet. That's the range I've seen, except for one guy I had many, many years ago. He was very tall and he was a basketball player and he had a pace that was well over 7 feet. But I've never had anyone even close to Mr. Levsack's pace. So, I mean, it's just unusual. He was definitely an outlier. But people 4.5 to 6 feet, 4 3/4, 6 feet all the time. So once you measure your pace, then you can measure lots of things outdoors based on what your pace is. But in the meantime, we get to do these things. So we need to convert between sets of units, and we need to convert within sets of units. So we need to be conversant with the US customary and with the metric system. All right, so that's what we're going to do first. And I'll take a look at some of the homework and we'll start talking about that. But the next thing I wanted to show you is our schedule. I've laid out our schedule between now and October 12th, which is the day before our midterm break. So during the week from the 9th, 10th, 11th, and 12th, we'll be taking our midterm exam. Once again, because this is an online class, it's a hybrid class, or high flex is what they call it. There's not one particular time that you have to take it, but I'll give you a variety of times and you can choose. You can also take it with me on Zoom, or you can take it face to face. But basically, what we have is every single day, I have a class number and then a video that you'll watch. What I'm doing right now is video number 1. So you guys are already, you're 100% right now. And then whether we're going to meet face to face or Zoom, you never have to be here. You never have to be online. You can always watch it asynchronously. It's totally up to you. But occasionally there will be a day, and I'll fill these in, like we're going to meet today and Friday. You can meet face to face or on Zoom. Then other days, I'll fill in the blanks and let you know if we're going to meet, if there's going to be face to face, if there's only going to be a Zoom or whatever. On September 8th, I'm going to be off campus, so I'll just make sure that all your lecture materials are recorded for you, so it's asynchronous only. Then our midterm exam has to be either face to face or synchronous, but everything else can be one of those 3. All right. So, and I will update this continually to make sure that it's 100% correct. All right, so we've talked about homework, we've talked about the syllabus, and we talked about the engineering comp paper. And what questions do you guys have for me at this point? All right. All right, so the next thing is, where is my unit conversion worksheet? What's that? They put it up here. I wonder if I put it, hang on. There, no. It isn't, oh, there it is. Unit conversion handout right there. Okay. So this is the first homework that we have. And basically, what it is just a handout from a textbook getting us used to the idea of converting units. And of course, because this is engineering, it's also, there's a form that we want to do it. We want to do it on the engineering comp paper, which you can just come down to my office and get some. And then you want to make sure that you have that as well. And we'll see if Microsoft, there it is, it loads up. Okay, so basically, can use this view only. There are several problems here. I don't want to sign that, I just want to look at it. Is it going to close for me, or am I going to have to do something? Oh, well, let's just do one up here. We'll do a couple. So like on number 1, we have 16 inches is how many centimeters? Okay, so let me stop my share and look at this. Okay, so 16 inches. Now, first of all, there is nothing here that you need to memorize. That's the piece that I want to be clear with. It would be irresponsible of you as an engineer to think, I think there's 2.2 pounds in a kilogram or something like that, because you can get in, there's actually cases where people have got into a lot of trouble with that. So after I do this problem, I'll tell you a couple of horrible examples. What you do is you find what's called a conversion factor, and you can find that on a chart, you can find it on the internet. You can just say, the one thing you can't say to get the right answer, you can get the right answer, but how many centimeters are there in 16 inches? That's not okay, but you can say 1 inch is equivalent to 2.54 centimeters, which is the conversion. Now we'll talk about scientific or not scientific, well, we'll talk about scientific notation as well, but every conversion factor for the purpose of significant figures is considered exact. So in other words, the data that you put in determines how many significant figures the answer has. So in this case, the answer will have 2 significant figures. So we have 16 inches. If 1 inch is the same as 2.54 centimeters, that means that 2.54 centimeters over 1 inch has a value of 1, which means it's a unit, which is why it's called a unit conversion. And similarly, 1 inch over 2.54 centimeters is also equal to 1. And so that means we can multiply anything by either of these fractions. So if we have 16 inches, inches is in the numerator. So we want to use a unit conversion that has inches in the denominator, because we know that things cancel from the numerator to the denominator, numbers and units alike. So the answer is 16 times 2.54. And I bet if I don't have a calculator, I bet one of you guys does. Who's got a calculator handy? Yes. And tell me the whole number that it prints out. 20.6. Thank you. All right. So 40.64, and I'm left with centimeters. Okay. And so this is numerically the answer. However, I only get 2 significant digits, so I need to report this as 41 centimeters. Okay, and that would be the answer. But so this is the process for how you would do that unit conversion. Now, sometimes there are a few, like down here, rates and volumes. For example, so let's see, 35 meters per second. This is number, and these are your homework problems. So, you know, so you're already getting some homework done today too. But we have 35 meters per second, and we want to change that into miles per hour. Okay, well, we can do this quickly, or if you don't know if you don't know stuff, you might say, well, and if you use not a bad conversion, but if you use an approximate conversion factor, it's okay. But for example, we could say, how many meters in a foot? I'm showing you, I'm making this a little bit more complicated than it needs to be. Okay, so we find that 1 foot equals 0.3048 meters. And what do we know about seconds and hours? Well, we know there are 60 seconds in 1 minute, and then there are 60 minutes in 1 hour. Okay, so now we have everything we need to do to convert that. So you start with 1 unit. We want to convert this to this first. Okay, and then we'll worry about the time. So we start with 35 meters per second. We know that 1 foot per 0.3048 meters is a unit. Okay, and then we have seconds here. So we could say there are 60 seconds per 1 minute. And then we could also say there are 60 minutes per 1 hour. Okay, so we convert by canceling meters, canceling seconds, and canceling minutes. Then we are left with feet. Oh, I did that wrong. Meter, feet. There, no, I did it right. I just wrote it down incorrectly. So, oh, I want miles. Okay, so I got to get, so I've got feet left over here. So that I also know that there are 5,280 feet per mile. So I have feet on the top. I don't have 5,280 feet on the bottom, 1 mile on the top, and then those cancel. So numerically, I have 35 times 60 times 60 in the numerator over 0.3048 times 5,280 in the denominator. And the units I'm left with are miles per hour. And what is my numeric value? 78.29 miles per hour. And I think that's right. And once again, I have 2 significant digits. So this has to round to 78 miles per hour. And there we go. So that's how you'll do this. And so, but the process is as big a deal as the answers, I guess, is what I'm saying. Just going to make sure that's shared a little bit here. No, it's wrong screen. All right. All right. So do you guys have any questions at this point? All right. So this is what we're going to be working on. I think I've covered everything about the class. Now we just need to talk about a little bit more about the syllabus, looking at our text and so forth. You can use a lot of different versions of the textbook. It has to be by Beer and Jonathan. It has to be published by McGraw-Hill. But if you don't have the most recent edition, the older editions are considerably less expensive, and you can still use them. The only thing that you need to do is to make sure that, let me share this screen because we need to get that on there. There we go. The only thing that you need to do is to not cherry pick the homework problems. So in other words, if it tells you to do 3, 6, 9, and 12, you want to do 3, 6, 9, and 12 from the same textbook. It doesn't matter which textbook, but if you say, oh, I like 3 from this textbook better and 9 from this one better, you may miss something important for a quiz or an exam. So it'll all work as long as you do it from the same. And you can change from chapter to chapter as well. If you have one book one time and another book the other time, that's fine. But just chapter by chapter, always do this homework from the same book. Okay. All right. The next thing, once we've got the book out of the way, is the grading system. And like I said, I will never grade down, but overall your homework will be worth 10% of your grade. Your quizzes will be worth 10% of your grade. Midterm exams worth 40, and the final exam is also worth 40. So everything that we do is working toward getting you ready for the midterm and the final exam. When you take the midterm and the final, it's timed and it's proctored, but you will be allowed to bring in a study sheet. So once again, you don't have to memorize how many feet there are in a mile, or if the sign is adjacent over hypotenuse or opposite over hypotenuse or whatever. You can write anything down. So you get a sheet like this, you write it out in your own handwriting, and you can make it as small as you want, and you can write on both sides, but it has to be in your own handwriting. And the reason for that is it's just a really good study technique to get ready for an exam like this, to spend that time sort of summarizing your thoughts and putting them on paper. So once again, the purpose is to get that done, get that down. All right. All the homework has to be turned in through Moodle. I do grade the format as well as the work. I mean, if it's not, it doesn't have to be perfect. Like if you circle something instead of underline it or something, I mean, that's not important, but overall it needs to look really good. You need to spend a little bit of time pulling it together and thinking about this as being a future engineer and writing things out for your boss, who may or may not know as much as you do about what you're telling them. So this is an important thing. So make sure that you're clear and make sure that that everything looks good. I can read people's handwriting like you cannot believe. So if you have bad handwriting, it's still fine. So I had one kid years ago who was really nice and really smart. And I swear he looked like somebody was making him write a ransom note with a gun held to his head. So, and I managed his, I can manage yours. So doesn't have to be beautiful, but just has to be organized. All right. So all the homework has to come in through Moodle. All the quizzes have to come in through Moodle. And the exams are proctored either face-to-face or on Zoom. Or in a weird situation, once in a while, if you're somewhere else and you can't do Zoom, if you have an adult in a position of authority, they can also proctor your exam. So I've had coaches proctor exams. I've had one time I was teaching fluid dynamics to a kid who was working on an offshore oil rig, and his drilling superintendent proctored his exams, just anything like that. But the best way is for us to be in a room together. And the next best way is for me to proctor you on Zoom. And the next best way is for you to have a librarian or a coach or a boss proctor for you. All right. So you guys have any questions? All right. Well, you guys have watched lecture 1 then. You are set. This will be posted to our page. And Hang on, let me share the screen one more time. There we go. So lecture number 1 will be right here. Here's lecture number 2. It's already there. It talks a little bit more about units and conversion. We'll have another lecture posted up here, which is what we did today. And then we'll move forward from this point. So I will be here Friday. If you are here, that's great. And if not, just make sure you watch the lectures according to the schedule. And then at any time when you need help between class, you just have to make sure that you get a hold of me and I am available to help you. So, all right. Well, that was great. You guys I'm going to go ahead and stop recording. Here we go.